This is class 1 gauge block, 100 millimeters long. It has accuracy error of minus 0.3 micron. It is made from steel and coated with oil, so it has to be degreased before use. 100.01. Because my room is not 20 degrees, it's 27. So at this temperature, the gauge block is going to be longer, and the alpha value is 12 times 10 to the minus 6 per meter per degree Celsius. This vernier caliper has accuracy error of 2 micron. Next, I'm going to test it with the Sermoon X1 in parallel line mode. The gauge block has a mirror finish, so I have to apply the spray, a very thin layer of the spray. Sermoon P1. You get the lowest accuracy error in 7 line mode because the camera is closer to the scanning object. After each use, you need to coat it with the oil and wrap it before you can put it in a storage, otherwise it's going to get rust. Okay, next I will also test the precision of the P1 and X1 with its standard angle block. It has angular accuracy error of 0.001 degree. So this is a good method to check the geometry precision of the 3D scanner, because in reverse engineering, angular precision is also as important as the dimensional accuracy error. Sermoon P1. Okay, this is the block scan from the X1. I draw a red line here, and next I'm going to offset this line by 100 millimeter. So the line will be landed here. Okay, if you look at the end of the line here, you are going to see that 100 millimeter is very close to one end of the point cloud. So I'm going to measure the center of the point cloud here. It's going to read somewhere around 18 microns. So when taking thermal expansion into account, Sermoon X1 has plus 10 microns accuracy error. Okay, this will be the scan from the P1. Okay, this will be starting point, and this will be the end point. Next, I'm going to offset to 100 millimeter. Let's see where it lands. Okay, so the P1 is shorter, X1 scan is longer, so they are different. Let's check the accuracy error. Oh, no, it's not bad, 39 microns. So when take thermal expansion into account, Sermoon P1 has the accuracy error of plus 47 micron. Okay, this will be the X1 angular error. It has to read 90. Okay, now it's read 89.994. The angular error of the Sermoon X1 is 0.006 degree. And for the Sermoon P1, 89.987 degree. The angular error for the Sermoon P1 is 0.013 degree. As you can see it here, the Sermoon X1 has much lower accuracy error than the Sermoon P1, and it falls into the class 5 precision of the measuring tool, comparing with the class 7 of the Sermoon P1. And this is the real-world method of evaluating the accuracy error. The dimension was taken from the 2D sketch in CAD. So the parts being reversed by this scanner will have this accuracy error. The wall thickness of the point cloud has been taken into account with this test, and it can be used to measure a tight tolerance mechanical part like this valve locker, gear profiles and camshaft, taper shaft and key. These are the kind of parts that require IT5 precision level for measuring. The Sermoon X1 is marketed for high accuracy 3D scanning. They advertise the accuracy area for plus or minus 20 micron. I made this video to prove that this is true or not, and it already proved itself that it is true. This is a very high accuracy 3D scanner. But what is not true, when using in the combination with the scale bar, the accuracy will fall down to the level that is not acceptable, more than 100 microns. They should exclude this from the package until it's actually work. Cut down the price. Maybe this toolbar would cost like $500 When it works, sell it as an option. A Wi-Fi bridge is useful in some cases, but not everyone needs it, so they should sell it separately. Maybe they can put the price down to $5,200. But this is already much cheaper than the other professional grade 3D scanner that costs somewhere around 15K to 20K. Here's my thoughts on the X1 3 months review. No issue yet, still working fine. I highly recommend if you do the engine or the machine part scanning. Thanks you guys for watching. I'll see you in the next video.